Was it on? It's on. I turn it off now. Do I just hit this to turn it off?
It needs to be on too, so we can record the other.
Yeah, I think. Is that? It's on. How do I turn it off though?
We've got you covered here. Turn your right on. You go with music? Music with a video?
Yeah. Alright. Well, I'll wait for Ben to come up. No, it's a oh, here's Ben now. Maybe we get everyone's
That's better. Okay, hi everyone. Thanks for coming. This is the number 2 in the second life of the computational design group meetings, and we've never had this many people before. And it's pretty amazing. I've been watching the numbers sort of climbing all week, and we got to 49.5, and it looks like at least everyone has turned up. Possibly people who didn't sign up have turned up. So it's good that we got a lot of pizza and extra beer. So, sorry, I've got a bit of feedback. Are you fiddling with that, Matthew? Oh, there you are. I thought you'd never ask. So, we've got 2 speakers tonight, and they're quite different. One of them's Paul, who's going to talk about his work on making residential design a bit easier. And the other one is Joanne, who's somewhere else. There she is. And she's going to be talking about her work on a kind of anthropological study of people like us who use tools and how they use those tools and their attitudes to tool use, tool making, all that sort of stuff. All the kind of exciting stuff that we talk about when we're sort of 4 or 5 beers deep. So, Paul's been with us with us at BVN for how long now?
1 year.
1 year, wow. And he's been doing some amazing work in making design processes easier and being embedded in projects and doing all kinds of stuff like that. So I'm not going to faff around too much because Paul will do a perfectly good job of introducing himself. But here's Paul.
Thanks. Hi. You guys might want to come forward a little bit. Don't be shy, there's plenty of space. It can be quite hard to see from back there. So today I'm going to talk about some of the research that I've been doing here at BVN on and past year. And it's focused on automating residential design. So a little bit about me. I'm a registered architect in the UK, and I'm currently a senior associate here at BVN, and I've been doing a lot of the computational stuff, and there's several of us in the office that are working on this. Currently teaching a master's studio at UTS, and later on this year we'll be teaching a Dynamo elective at UNSW. I'm also the founder of a website called and that's a website dedicated to improving the computational literacy of architects like yourself. So about my interests, love a pixel flying across the screen in processing. I guess my main interest is more about sort of applied computation. So taking what we know about scripting and how we can implement that straight away in practice. So a lot of what I do is trying to get Grasshopper users speaking to Revit users and developing workflows that link the two. But also about automation of different building typologies. So one thing that sort of breaks my heart is when I see people working on really repetitive projects, certain typologies, airports, hospitals, residential, and they're doing everything manually. So what I'm going to show you tonight is sort of research about how we're addressing that here at BVN to sort of automate some of those mundane processes. So this all began around 9 months ago, and there's been a massive residential boom in Sydney and probably all through Australia. So architects in general have been inundated with projects, and so about 9 months ago we had about 6 computations running simultaneously in the office, all different ones. This one was O'Day Avenue, Glebe, Bayswater Road, Big Epsom, and Small Epsom. And these were all being developed by different groups within the office. So I spoke to 2 of the principals here, Matthew and Anoshka, and I said, well, okay, how can I help? And they said, the 2 things that are really time-consuming is how can we automate CEP 65 solar compliance? It's a big pain in the arse, it takes a lot of time, and it doesn't necessarily influence the design. We have to sort of evaluate it, and we're evaluating it at the end of the design process when it's sort of too late. I'm like, fine. And the second one was, okay, well, I think this was sort of like on their wish list. I'm not really sure they actually meant for it to happen, but how can we actually automate the project feasibility? So we spend a lot of time in Excel calculating if all this program can actually fit into the building. Really time consuming, and when we're working on a competition, we may have 1 day, we may have 6 weeks. So we need to be... If we look at the first one, CEP 65, I'm like, great, no problem. What the hell is it? And having been out of the country for almost a decade, I had no knowledge about CEP 65. And so I started researching into it, asking various people in the office. And originally it was a residential flat code. It's recently been amended to the apartment design guide. But basically the clause that is causing us and many architects in New South Wales problems is this one, which is the requirement of 70% of apartments in a building to receive a minimum of 2 hours of direct sunlight between 9 a.m. and 3 p.m. in midwinter. And I'm like, that's kind of specific. And they have a whole bunch of these diagrams that say, okay, this is how a building should be orientated, this is how big ceiling heights need to be, etc. And so while I was used to other countries with an emphasis on thermal performance, it seemed here that there was a very strong emphasis on direct sunlight. And we'll sort of come back that that's actually a good or a bad thing. So I'm like, well, okay, well maybe that's quite a logical thing to happen. Surely someone's done the research and 9 till 3 is kind of logical. But what we find, according to Steve King, who's one of the expert witnesses that many architects use when they go to the Planning Environment Court, is that this originated from a book published by Walter Bunning back in 1945, which talks about essentially the same thing. Residential design has come a long way since 1945, so it is a bit questionable about whether this is actually relevant to sort of multi-residential buildings. But nevertheless, we pushed on, and so utilising Ladybug plugin within Grasshopper, we developed this script which basically takes the massing of the building and the massing of the context and calculates the direct sunlight for a given day, so the 21st of June, between 9 a.m. and 3 p.m. So what we can see here is we're actually referencing a weather file, an EPW file, which we download from the US Department of Energy. So we browse to Australia and then to New South Wales and Sydney, and we simply download that. And that file has all the information already embedded into it. It has the latitude and longitude, it has amounts of rain, temperature, all of that information. So we're just using a small fraction of that, mainly the latitude and longitude, to calculate these sun vectors. So the script's set up quite simply. Parameters on the left, which are a series of questions. So do you need daylight savings? What time of the year do you want to orientate? So that users don't actually need to know any of the code. They just respond to those initial questions. Functionality in here, which basically color codes the mesh relating to the number of hours that each mesh face receives. And then we can simplify that into two colors, the area that complies and the area that doesn't. So one of the difficulties with SEP65 is that it's so specific in that in order to do a full compliance check, you know the position of every living room and every balcony in the building. And that's kind of the real fundamental problem, is that you need to know the building before you can evaluate it, and by the time you've done that, it's sort of too late. You end up shifts here and there. So this is really a tool so that we can get an idea of the percentage of the surface facade that complies before we get too far down the line. So the next thing is how can we automate the project's feasibility? Mount Everest to climb. As architects, we've all studied sort of 5 or 6 years in design. Surely the project is too complicated to be synthesized down to a set of rules. But if we actually look into the incredibly descriptive need what the maximum GFA is allowed. They tell us what the space between buildings need to be. They give us the angle and the distance between all of it. Okay, is that on? So they give us the distance, the angles of all of this information. They even tell us about internal amenity, what's good and what's very good and what's okay. We also get a series of examples on what they consider, possible good exemplars of these rules in practice. So, if we think about trying to automate this into an algorithm, in 1992, Hersey and Friedman developed an algorithm which sort of, I guess, calculated a lot of Palladio's villas. So even though Palladio was working back in the 16th century, the rules that he followed were very systematic in how he laid out his buildings. So although he wasn't explicitly working with computation and algorithmic design, the methods that he was using were very much along those lines. So it can definitely be done. So I guess where we started with this was first to just look at simple sort of massing of the building. So one of my favourite tools at the moment is Elephant, which is a plugin developed by Ramond, who works for Front in Hong Kong. And basically this allows you to embed data into Rhino objects. So rather than having to manually reference objects, you just put it on a layer and give it a name, and Grasshopper automatically reads that. So here we see a bunch of polylines which represent the outline of the building. I've told it how many levels I want to extrude it, and it knows the floor-to-floor height, and it automatically extrudes it. It then starts to contour those buildings so that we get the floor plates of each of those levels. And it returns sort of simple metrics about what the maximum gross building area is and the area per floor. So the next thing to do is go, okay, that massing's great, but can it fit all the information or all the program that we actually need? So we'll run what I call basically a glorified Excel spreadsheet, but we're doing it in Grasshopper. And we use a series of assumptions. So on the left we say, okay, we know from previous experience that the efficiency of a building, depending on the circulation strategy that you use, could be anywhere between 75 to 85%. So we know the rough size of our building. We have an idea of the circulation strategy that we would like to implement. And so we enter in these parameters, and what it returns is takes the gross building area and returns the gross floor area and the net sellable area. And this net sellable area is the area that we're interested, that we use in later. So that basically gave us the framework in which our building can operate. We now have a maximum building envelope. We know that our area can roughly fit inside there. So the next thing to do is to look at how do we actually populate it with apartments. So back in the early 1990s, Thomas Ray from the Santa Fe Institute, he was an ecologist, and he was studying sort of genetic algorithms and genetic evolution. But what he discovered is that's a bit problematic because evolution takes, many millennia to actually happen. So you don't actually see many changes in your lifetime. So he developed this software called Terrier, which started to simulate this genetic algorithm. These days we don't need to do that. We have Galapagos, which is all free and readily available within Grasshopper. So I'm sure most of you guys know how this works, but we have a series of genomes which are randomly populated, in this case on a fitness topography. They then breed and kill off unfit genomes, and so eventually we start to work our way up into the more fit areas, in this case being the top of the hill. So for us, the way that I define fitness for this, and we'll come to the limitations of that, is purely on efficiency. So we know what the floor plate needs to be. The next thing that we can do is we can say that we're going to limit the number of apartments per floor to 10. So if we assume we have a maximum of 10 apartments of 1 beds, maximum 10 apartments for 2 beds, etc. We have 11 to the power of 4, so studio, 1 bed, 2 bed, 3 beds. That's roughly 14,500 possible combinations that we could use on any one floor plate. So we could have 1 studio and then 0 1 beds, 2 beds, 3 beds, or we could have 2 0 0 0, etc. So what we're doing here is we've run a brute force algorithm which calculates all of those different permutations. We're exporting it out to Excel, and because we have an idea of the average size per apartment, we can start to populate that just through simple Excel formulas, and we get a fitness, which is an area value of that combination. So obviously a mix of 0, 0, 0, 0 is going to return 0 square meters. But if we know that a 1 bed apartment is roughly 50 square meters and we have 0, 1, 0, 0, the fitness value is going to be 50. So now that we know all of the possible combinations and we know what we need per floor, we can start to find the top, say, 10 mixes that would work on that floor. So here we're using basically just re-importing that information from Excel, and the reason that we do it via Excel is that this can take around 30 minutes to run. So what you don't want to do is make a mistake and then have to wait 30 minutes to run it. So we run it once and it sits on the server and it's saved there. We don't need to rerun it again. So what we can see here is we know that a floor plate is, say, 800 square meters. So say return the top 10 mixes that will get you close to that 800 square meters. What it also does is it gives us the unique floor plates. So if we have a tower, for example, we don't need to calculate every level of that tower. We just calculate it once and we can assume that this is sort of pancaked and stacked on top of each other. So now that we have like the top, say, 10 values, that's working on a fitness on a per level basis. What we actually need to do is get a whole building analysis. So often, the clients will give us a breakdown that says 30% 1 beds, 50% 2 beds, etc. So yes, it's great that you're highly efficient on this one level, but can you get all the apartments we need with the correct ratio and get it all stacking? So on the bottom left, you see our genome input that's being run into Galapagos, and that slider represents one of those apartment mixes. And we're actually, we can control this by setting, or giving it a penalty if it doesn't stack, if we want it to stack. We can tell it if we have a preferred mix. So if we know in the tower we want more 3-bedroom apartments because they sell better and have better views, we can say prioritize that one and work around it. And so as this starts to run, what you see on the left is those values start to stack. And we get sort of 3 or 4 different tiers. and that relates to those tiers of the building. So we have one mix which is repeated within that tier. It then changes. So the way that we've been using this up until now is really, I guess, a glorified briefing document. I can go to the principals or the project architect and say, this is how many apartments you need, this is how you can distribute it. I haven't worked it out, but I'm sure that you can work it out. And if you place this many apartments on these levels, you're going to hit all your numbers. But that kind of wasn't good enough, and we wanted to take it even further. So I said, okay, so we know how many apartments we need. How do we actually place them, and how do we decide on which apartments we want to place? So I did a big data harvest from those 5 or 6 projects I showed you at the beginning, and what we extracted was around 20 different apartment types. The biggest variation is, I guess, 2-bedroom apartments. And so again, using Ladybug and Elephant, we run a simple solar tool. So again, that same 21st of June between 9 and 3, and we take every apartment, which is sort of pre-formed, if you will, and we basically take it through 45-degree increments. Now the new SEP 65 has just come out and it's slightly different, but the previous one required, again, highly specific, 50% of the balcony to comply with a minimum of 2 hours, and the living room floor a minimum of 1 square metre. And so there were 2 different criteria. It wasn't a simple yes or no, it was like you needed a tick box in both of those. So what we can see here is that certain apartments, even though they're both 1-beds, perform quite differently in terms of solar performance at different orientations. So here we see 270, so it's basically facing west, and then 315. And so the tendencies that we find, and again this comes back to SEP 65 and its intention, is that the one on the left performs significantly better than the one on the right. They look, apart from the rear of the apartment, they perform, similar sort of functions. They have studies and bathrooms, etc. But the main difference is that the living room, on the left, the living room is out on the facade. And the bedroom is inward of the balcony, and that relationship is flipped in the option 4. So, it would be nice to have the flexibility to choose which one we like. Do you want to be in your bedroom and be able to kind of see into the living room and vice versa? What I would argue is we don't really have that option. It's sort of taken away from us because we need to comply with this 70%. Yes, we can kind of go to the council and argue for alternatives, but in most cases developers want an as-of-right development, so they don't want anything that could disturb getting approval. So we always go with the safest sort of route, and that means using layouts which are, I guess, more compliant in terms of SEP 65. So I guess the way that we've been addressing this to date has been based on efficiency and also SEP 65 compliance. And I guess there are several limitations of this. First is, there are lots of different variations. We can start to introduce the mirror of each of these apartments. But the idea is that once we have all of this and we know the massing, we know which way the facade is facing through the normal of the surface. we can then start to determine which of these apartments would be better suited to that facade. And so we're working on the automation of that, and so hopefully that will be ready soon. But in terms of the limitations, as I said, we're working with efficiency in SEP 65. And as we know, that's not the be-all and end-all of architecture. And so in parallel with that, we're running a embedded practice studio at UTS called The Fitness of Politics. And really what I've asked the students to do is to come up with an algorithm that defines what residential living is for the 21st century, for 2015. So what we're doing is, it's really a reaction to this. So this is Michael Wolff in Hong Kong, the kind of the repetitive and sterile nature of a lot of residential developments around the world. So this is some research done by Leanne Hoddle, who's a planner down in Melbourne, who looked at various cities around the world, and what she discovered is that Melbourne is actually 3 times more dense than some of the densest cities in the world. So we can see a comparison between Melbourne and Hong Kong. And so what I've asked the students to do is to look at these cities and extract the planning parameters that are most, I guess, fundamental in controlling the building morphologies of those cities. So in Sydney we have SEP 65, in London we see right of light, in Hong Kong we see some interesting planning requirements where if you do a bay window it doesn't count towards GFA, so everyone does bay windows, not because they like them but because it's free area. Singapore has a unique scenario where if a building is not more than 6 stories, then it has a relaxation in how it calculates GFA. New York obviously has the setback from the centre of the road. So half the students are looking at the cities, the other half are looking at these precedent projects. And starting to look at how those principles have been manifested in the built outcome of this. So we can see some of the students' work. So this is from Carlos, who's in the crowd down there. This is One Central Park by Jean Nouvel, just down the road. So a lot of these buildings are by the world's, most famous architects, and so what we want to do is see, okay, well, how do they do it? Like, is it really hard? Is this why we're getting really boring buildings? And if they can't do it, then can anyone do it? So studying all the different metrics of those buildings, how the circulation works, what the unit breakdown is, kind of apartment distribution, numbers of apartments per floor, etc. This is again another one by Alexandro. He's looking at Herzog de Meulen residential tower in New York. This one's quite unique in that each of the apartments is basically 1 per level, so it's effectively a penthouse with 360-degree views. So what we're hoping that we get from this study is a series of rules from the cities and a series of rules that we've seen from these precedent projects that we can then start to Frankenstein together. That we can say, okay, I really like what Sydney's doing with SEP 65, but what it needs is really a bit of influence from New York or Singapore or a bit of Jean Nouvel, to really make it complete, and so that it's not just solar based, but that it builds in all of these other factors, circulation, sense of community, all of these other things that we think are actually useful for today. So this is where we're at. This is work in progress. The studio is about to have its interim review next week. And so hopefully in sort of 6 or 8 weeks' time, they should have some grasshopper algorithms which start to piece together all of these different planning legislation to come up with their own, I guess, proposal for the future. Thank you.
So, what was I going to say? So, do you guys have any questions? Is this working? Did you?
No, it's still on.
Okay, you have that one.
That's scary. Does 765 make federal partners?
Oh, you tell me. I think from the discussions we've had in the office, it's, I guess in general it's good that it builds up or raises the lowest common denominator amongst architects, particularly the less competent architects. But what we find is that it does restrict freedom of those architects that do have the capability to do things better. So maybe from the city's perspective, yes, it's a good thing. From our perspective, it makes things a bit harder.
Can I ask that question in a slightly different way? So, do you think the way that 765 puts the solar amenity attribute, whatever you want to call it, so high that it ends up driving everything in the scheme to the potential reduction of other forms of amenity?
I'm not really sure why the solar component has got such prominence. Read through the guide. Can I just not use this?
Microphone's off. On. On. Yeah. Well, a bit of walking around will do you good. It's really weird. So this isn't too bad. It's fine now. Okay. Well,
Actually, I think we have a purpose saying something about people who are like technophobes, but they're actually. Shall we read it out loud? Actually, read it out loud.
see you soon. Nice to see you. Give me a shout and we'll have a coffee. Do you know Christian? Yeah. I would imagine so. It wouldn't surprise me, most people. Oh, yeah. Okay, guys. I don't want to interrupt too much hobnobbing, but there's plenty of hobnobbing to be had in a bit. And for those of you who are kind of sat on the uncomfortable seats over here and perching over there, there's if you get in quickly, you can have one of the comfy seats. Yep. So tonight's next speaker is Joanne Taylor, and I first met Joanne when she interviewed me for this study, I don't know, 6 months, a year ago, something like that, sometime in the past. I'm not very good with time. And she asked me all kinds of really interesting questions, and from that point forward, I've been really interested in this research. So people have attitudes to the way they work. They feel like certain things identify them. They're able to decide who they are because of the way they work, and people have inbuilt resistance to changing. And so Joanne's been doing a whole load of really interesting work on that. So I'm just going to introduce Joanne.
Hi. Ben makes it sound a lot more interesting than it might be in this presentation. But what it basically is there's a number of researches that I've been undertaking into understanding human behaviour around tool use, and particularly in architecture. How many are here from PTW? Is that like 4? They've all left. You guys, oh no, there you are, wonderful. I'm so glad that you guys are here because you're actually part of the research, as was Scott Carver at the time, which I think we have 1 here at the moment tonight. But so basically there were 2 research projects that were undertaken. One was an in-house kind of BVN research. It was done on much more of a micro scale, and the other one was done more on a macro scale, and that was really looking at 40 different architectural practices in Sydney and Melbourne. So the 2 research aims varied, but they followed on from each other. So the first research was really about an examination of the tools and the methods applied to them in the design process within the practice of Australian architecture to see if the tools were actually affecting our design outcomes. And the second one was much more about understanding the attitudes and behaviours towards tools and technology in delivery of architecture. So what first got me involved in this research was just this incredibly curious mind. So I completed my architecture degree as a mature age student, as difficult as it was. And as I completed it, I was fortunate enough to be one of the first students that went through completely digitalised. So we had Maya and Rhino and SketchUp and a bunch of other things just thrown at us. Am I blocking out here? And part of that process, I became very self-analytical to try and work out whether these tools were having an effect on our outcomes. So this research is really a trajectory of that. Some of the questions that I was interested in were our design processes really reflective of or responding to the tools that we were using? So in other words, we use SketchUp. Do our buildings look like SketchUp? You know, we use Grasshopper and Rhino, and we do kind of geometry kind of component designing. And is that all just a product of the tool that we're using, or are we actually creating our own thinking over the top of the tools? And then really, were we complacent about our search for new tools and processes? These are the participating firms. There were more firms from Sydney than Melbourne. That was not for lack of response. I actually had 150 people respond to me that wanted to engage in this research. So people were really interested in discussing design. They were really interested in discussing the tools that they use. I unfortunately was just constricted by logistics. I live in Sydney and I had to travel down on Tiger Air on a budget to get to Melbourne, and it was horrendous. But the people in Melbourne were lovely, and they took hours and hours to talk to me, which was even more laborious. So the definition of design tools, what are design tools? Well, for me it was really liberal. It was those instruments which aid in the initiating, the communicating, the testing and developing of ideas. They could be categorised as analogue software tools, research tool, conceptual tools. I wasn't limited when people said that thinking was a tool. It's a tool. You know, like if taking pieces of paper or furniture, it's a tool. Like everything is a tool. Everything that contributes to design is a tool. So the methodology was really qualitative interviews. I went into everyone's studio and interviewed them personally. There was only one studio that I didn't interview personally. That was by email. This in itself was really fascinating. Like when you go into a whole range of architecture studios on a collective and just start to understand how they practice, how they operate, how they set their studio up, really, really fascinating. So that was like a bit of a side win for me. I asked them some really simple questions because I just wanted to know simple answers. And I just said, how many people work in your office? What type of projects do you work on? The budgets? What tools do you use to develop your ideas? And in particular, what methods are you applying to the tools? Which was a really interesting point for me because I wanted to know how people were using CAD or Rhino or sketching and how they were using it together in collaboration with other people. And so with what purpose or intent do you use your tools? And do you really kind of combine tools, and how often do you combine the tools? So really, how are the tools operating together? This was a reporting format that I used. It seemed simple at the time, but in the simplicity there was an incredible amount of information. So it basically was, what was the tool used, what was the intended outcome, and what was the method applied. And so this kind of circular diagram that you see is really that it's indicative that it was an overlaid pattern and it wasn't really a linear pattern. And whenever you see this line come down, it describes it was quite linear. And this is BKK Architects. I've specifically popped their model in because they were the one and only innovative practice out of all the ones that I interviewed. And I didn't interview BBN, so I can say that. And in PTW, I'm not having a go at you by saying that. But when I say innovative, they were the only one that was searching for new tools and new processes and putting all their budget, like 10% of their budget that they made, they put back into searching for new tools and new processes. And they knew that money was going into whatever it was, a blank canvas, but they were really, really interested in how this could change the face of architecture. So when you're looking, this was 2 years ago, they were already into like Grasshopper and Weaverbird, and they were looking at topo structure, and they were looking at how they could actually affiliate with other institutions and research institutions like RMIT and engineering departments to have alternative outcomes. This diagram is quite interesting because I think we've got a pretty large architectural audience here, so even though it's a comp meetup tech kind of thing, I'm going to talk to a bit more of an architectural audience at the same time. Back then, Revit really was only 13 out of 40 people were using, or 40 practices were using Revit. I'd be really interested to do this research again to see what kind of practices are using Revit. The main tools at the time were still pen, paper, sketching, a whole range of other things, and even Rhino was ahead of Revit at the time. So the 6 patterns that emerged from this research, very briefly, I'll go through them, but they are just titled the industry effect, the education connection. There were collaborative models, a range of collaborative models that came out, and they all varied. There was the death of the tactile, meaning the model had gone. The agency of architecture, meaning the kind of intent that you design with has an effect on the tools, and a uniformity in methods. So not surprisingly, I guess, and kind of boringly, industry effect. So tools chosen were largely dependent on the efficiency of the tools to get the job done. Those tools that got the job done fastest. Speed, budget, delivery, they were all influencing and prioritising over design. Then there was the education connection. So you see these generation gaps between the older school architects and the younger school architects, those that are the pen and the paper, and they come in, and then the younger ones that have all been trained on Maya and Rhino and a whole range of other things. And you get these cultural clashes, and you think, wow, what the hell is going on there? And it's probably the most exciting part of the research, because we're on this precipice, this kind of time of change where there is a cultural clash. And eventually the older architects will disappear in about, I give them another 16 years and they're gone. I know that's a bit rude, but like they're going to be gone, and this new generation of architects are coming in. So really still the tools are staff dependent, and staff fluctuations cause these variations in the types of tools used. The tools are largely influenced by generation and by education. Very new tools appear to be emerging in practice other than the stream coming in from universities. And at the time, and still now I'm sure, but there's a lot more plugins at the moment, Rhino, Maya and Grasshopper were 3 of the newest tools to have gained some kind of legwork and popularity. I love this image. 1, because I'm really old, and 2, because it's kind of like what everyone does when you mention the word collaboration. Like, what the hell is that? Collaboration, there's like 3 different definitions here of collaboration that have been stolen off the internet. We have got, I'm going to start from the bottom just to be unusual, we've got to work jointly with others or together, especially in an intellectual endeavour. United labour, cooperation, especially in literary, artistic or scientific work. And collaboration refers abstractly to all processes wherein people work together. It sounds really simple. There were 4 collaborative models that emerged from these 40 different architectural practices. And they all have their equal rights in being defined as collaboration and can be considered collaboration. So model A, it was the testing of ideas and the overlay. So that's really when 2 people get together. So one might be on sketching and one might be on CAD. And it could be a generation gap, or it could be just a different way that people work. So basically, they overlay the tools onto each other. So somebody sketches, sends it back to CAD, that CAD comes back, and then they sketch it again, and this relationship kind of happens. Now, that really only works in an environment where there is a more of a stronger trajectory of an idea. So the idea has to come from somewhere, and then it gets carried through this process. The collaborative model B was the transformative process. There was a little less of this out of all the models, and I've put generalist specialist there because I think that the generalist specialist category fits most likely into this area. But that's when 2 or more staff operate with these variety of tools. So one might be speaking and has this idea and this dialogue, and the other might be working on whatever program. It could be a CAD program, and they're basically drawing out or sketching out or working out what they think these words mean. Now, in that process is a transformation that happens in the design, and the key to this kind of type of collaboration is that there's less ownership over the design. And so no one actually owns the design. Someone comes up with a design and then it's interpreted between the 2 people working on the different tools. Model C is really a simultaneous process. It's like, let's go away in isolation. I might have a model, you might have CAD, I might go and just do some sketching, you might do this, and let's come back together again and see how those ideas synthesize and come with some kind of outcome. And that's this process that continues to happen. The collaborative model D is really probably what I would personally consider, and I'm going to have my opinion here, is probably one of the most least collaborative processes, but it still classifies itself as collaborative, and that's just basically when you have a project and there is a number of people working and they all have different tools that they work with, and the project just gets passed through them. So someone might be brilliant on Photoshop, or someone might be brilliant on, I don't know, like Revit or whatever, sketching, and so just the project passes through them. And in a lot of circumstances when this showed itself, it was really more like they had a protocol, like a design book. The design book needed to be filled, and they just pass that around the office. So the death of the tactile. Okay, tactile, it's really, only 50% of practices were really using physical model. For those that were using the physical model, only 13 were using it actually in the design process to affect the design process. 10 of them used it for client presentation, and maybe 7 used for quick massing tools. So the reasons, though, for not using the tactile were that models, physical models are really, really slow. A couple of the forms, not the focus, SketchUp's, the new massing program, time and budget. And I think none of these things for anyone in architecture would be unfamiliar. And I guess, computers are the new visualization tools. Interesting. Those that wanted to save the model really wanted to save an understanding of the buildability of architecture. They wanted to kind of get this sense of scale and proportion. They wanted to have a kinesthetic understanding or a learning dimension to architecture. And they wanted to know how the elements go together. So 3D printing, Tim Black from BKK said quite perfectly, he said, you can 3D print, but does that really help you understand how a building goes together? No, it doesn't. So they constantly put buildings together through a range of different apparatuses. They 3D print all the time, but they'll do component building as well, just so they can understand how it all falls together. This was personally my most interesting, the pattern to emerge, and this was kind of like the agency of architecture, or the philosophy of why we design or what we do, and a whole range of other things. And there were 3 different patterns that emerged. One, this ideological position. So architectural practices have a strong sense of idea, and that idea carries through the entire project. So it does not matter what tool you use, and it does not matter what method you apply to that tool, as long as that idea stands really strong and really true. Design methodology, there were lesser practices involved in this, and the practices were sitting at about the 20 people mark, maybe about the 16 to 20 people mark. And so they would pull out a design idea with instinct or intention, but they'd let the tool inform the design in some way. So they would overlay a whole range of methods to the tools to see what outcome they could get. And the very last one was this idea of site, brief, client, practical response. They were the ones to understand all the tools to their innate parameters. Revit can do this, Rhino can do that, Maya can do this, whatever, and then they'd pass those around, understanding that, just to get the response. Overall, and I'm nearly finished, so I hope you're still awake. Overall, there was a disappointingly uniformity in all the methods applied to tools. So they applied the methods in the very same way. So there were very few people that were breaking out, applying new methods, doing new tools, having a look at new processes, which, for a whole range of reasons, budget, time, industry expectations, employability, market movement, which led to the next research, which I was very fortunate to engage with in BVM. And so BVM was much more of a micro research. So we wanted to get into the minds of people and their attitudes and behaviours and start to understand how people are using tools and why they're using tools and what's inhibiting them from innovation and adopting new tools into their process. So this is one last little diagram I'm going to finish on. It's kind of like a work in progress diagram. And how am I going to describe it? The way I'm going to describe it is the colours. So the pink colours actually reference why people don't learn new tools or adopt new tools. The blue colours reference why and how people actually learn. And the gradient of the colours is representative of the fact that it is the strongest reason to the lesser reason. So, for example, people on a micro scale will not adopt new tools into their practice because the project does not allow it. Now, when looking at this diagram, I'd kind of like you to look at, you've got the inner circle of scale, you've got the next level out, and you've got the final external environmental scale. And so I call these like scales of influence. And they're all working against each other. So, for example, you say the project doesn't allow it. Why does the project not allow it? Well, perhaps the process is not correct, or the process is inhibiting it, or the methodology is inhibiting it. The next reason was there is no time to learn new tools. And most people interviewed, and I'm sure people here in architecture might reference this, is if you have to learn any new tool, it's probably on your own time. Leadership, this is not a negative thing by any means. It just means that leadership is a little bit disincentivizing in the sense that managers are so busy and they're under so much time pressures that they're not even on the tools. So therefore, time again comes back to this pressure point. Inconsistency in how tools are used. All the new tools that are coming in, like those tools like BIM or Revit, require this really high collaborative environment. So if your management systems are not right, if your collaborative environment is not right, these tools, they're not actually going to work for you. You're going to find constant restraints and constrictions. And the very last one was this investment, this fear of time investment, because time is so valuable, and it's all on projects that if we invest time into tools, what else are we losing on? And so all of these kind of pink dots that we can look at really are having a force pushed against them by having a look at how the traditional process of architecture is delivered. So this idea of methodology, process, philosophy, value systems, management styles, they're still very much embedded in a traditional process of delivering architecture. How do people learn? Well, number one reason, well, they can focus on a task or a project, so it's got to be applicable to the workflow. Really, really important for learning. It's got to be real. Number two, human connection, osmosis. We actually all really like each other, and we want to hang around with each other, and we want to get information off each other. And I personally learnt Revit, as Angus would know, from an amazing kind of BIM manager that would just come and you'd pick up the phone, he'd be there, he'd talk to you. This is how you do it, this is what you do. So it'd be breaking through all those barriers. So this human connection is really important. Listening into conversations is really important. And the last way is, last dominant way is play and exploration. So let's explore and play without this detriment that we're going to actually fail. So I'm nearing the end of this talk, but basically what seems to be happening here is we also have these environmental forces that are coming back in. And so the environmental forces are, well, we've got clients, time, budget, speed, delivery, expectation, global competitiveness, and all that comes from this kind of identity and the value of what is architecture and what can architecture do above and beyond building designers and engineers and all these other people that are producing buildings at a rapid rate. So this kind of value, this question of what is the value of architecture is happening at the same time as we're getting these incredibly enabled working environments that are all about co-creation, co-design, like co-producing, co-sharing, collaboration, mobile workforce. So these are all these environmental influences that are acting against the traditional practice of architecture. And what seems to be happening in this model is that architecture, as opposed to pushing back on these environmental conditions, are actually pushing back on the inner circle and demanding more of the inner circle. Where in reality, you look at the inner circle and you think, okay, new tools, technologies, innovations, they're all really strong for change. So really what we should be doing is going back into the inner circle, caring for it, nurturing for it, and pushing that out onto these environmental pressures and having a look at new systems, new processes, new ways of working. So I guess in conclusion, I don't want to hold you too long, but in conclusion, we can see that this kind of middle band that is on the diagram is constricting innovation in architecture to a really grand scale. And it's not until we look at our processes, our methodologies, the way that we're working, our management systems, like innovation, risk, none of that can really happen in silo operations and in hierarchies because they're protecting themselves from risk. So we need to kind of look at the way architecture is really managed and look at the processes of architecture to get to any core of innovation and allow this impregnation of tools and technologies to push back on, I guess, global and universal forces. Anyway, that was a little bit of a manifesto at the end because I thought I had some fun, but that's it. Thanks.
Does anyone have any questions? So I've got a question. So in a lot of the work I've been doing recently has been kind of straight up software stuff, and collaboration is really easy because it's all through text files, and there's no your tool chain is entirely your own. You build a personal tool chain and you affect the text file and then share that with someone else, and they build their own personal tool chain. It feels like one of the biggest barriers to collaboration in architecture is that you have to use the tool chain that someone else forces on you. You can't use whatever you want. Is that something that came up, that people were saying, it's not my way of doing things, I have to do something else?
Yeah, definitely. Oh. I think I feel like you're leading me into the lion's cave there, Ben. I think one of the difficulties with being told what to do and being told how to do it is it actually restricts the capacity for this really vulnerable moment to occur where it's curiosity, inquiry, let's fail without consequence, let's enjoy ourselves. And so when you're being told what to do, it kind of, I guess in some elements humans respond with stress, or humans respond with a whole range of emotions to it, and they will do it, but it blocks off ownership. And the biggest key to any innovation is actually ownership. We need to own what it is that we're doing because we need to own the outcome and own the results. So it has a huge effect when people tell you how to do something and why you have to do it. Obviously, there's many reasons as to why we have to do things, and there's many reasons as to systems and organisations and to keep things in place, and that's really important. But yes, it has a very sad effect on ownership and sad effect on, I guess, design development, to be honest. Yeah.
I'm not sure what you commented, but I'm interested in the phasing out of the kind of older generation, not in a bad way. But I sort of find that problematic, and I'm not really sure what the solution is. So if you look at many of the architects, they end up designing what they already know. So like Foster and Partners, for the last 30 years still designing British high tech. You look at other architects, they're still doing what they know. They're just refining that process. Refine something rather than trying to reinvent it. And there's very few practices that have actually reinvented themselves. I mean, I can sort of think of Herzog and Murin, which still have their material focus, but now it's much more computational based. So if we're sort of arguing that practices need to be more agile in how they adopt software, I don't think that this phasing out is a solution, because in sort of 10 or 20 years or even longer, when this generation becomes more influential in practices, we'll be implementing technology that's then sort of 30 or 40 years old. And so how do you break that cycle? How do we get people that may not know the tools or the theory behind it to actually engage with that without having to wait 30 or 40 years?
I feel like there was 3 questions in that. Phasing out's not something that I think is fabulous. I think it's just something that's going to happen. How do you get people to engage in tools? I think there's 3 levels of tools. I think there is the, and we were speaking about this earlier, I think there is kind of the logic of the tool, there is the language of the tool, and then there is the understanding of how the tool works within a workflow. And they are really 3 different scales of understanding the tool. I think the difficulty that happens at the moment is people just look at a tool and just drop it. And they're not even ready to engage in a certain scale of it. So if management were able to engage in the understanding of the logic of the tool or how it works, that's enough. Like, they don't need to know the language or the full details of how it's applicable to the workflow. Or maybe they could know a little bit, but that's enough for them to actually grasp that. I think the response is a greater integration. So when we look at this generalist-specialist relationship, everyone thinks it's a really dirty combination. It's actually really kind of cool if people want to be a specialist and not get locked into that role, because I think you can't really innovate unless you know your tool. You can't really innovate unless you know what you're doing at all. And generalists kind of skim on the surface of everything, and they have to, because they've got to be over so many different things. So this integration of older school, kind of newer school is a much more richer and kind of fatter discussion, because it touches on so many different realms of it. But I think when you look at what collaboration is, we haven't even touched the surface of it. Like, collaboration, you can define collaboration in dictionary terms, but when you contextualize collaboration and when you say what is collaboration for an architectural environment, I think that becomes a lot more powerful. And that's a conversation that is only just opening. Does that answer it?
I don't think the way you're saying the 30-year lag. I think we're at a cusp where you're moving from completely hand-based techniques to completely digital-based techniques. Like, I was another person who joined a university at the point where it moved to digital only for the first year. And you'll get a group of people that slowly have a greater acceptance of digital software, and they slowly have a more incremental learning curve to get into new programs as they come out and so on. So I think you'll never get the same lag that we've got at the moment. Do you agree with that?
I think every generation thinks that. I mean, we're talking about sort of this digital technology, is that it's sort of, I guess, something new, but throughout history there's always been some technology, whether it's the invention of the flying buttress or the elevator, that's fundamentally changed how we design architecture. So it's sort of no different in that regard.
I don't know. I think the computer's on a bigger scale than that.
But it's kind of the same thing about 100 years ago. People said the image of the car, the plane, which is completely kind of different. That invention comes, and then there are another invention coming, and the challenge to know is different. I don't think there's a shift from paper to digital. It's just like a shift, doesn't shift over time. It just seems dramatic for our generation, because